All right, welcome to the final module of the class. This one is going to be pretty basic as far as the lecture goes and how deep we're able to go. Pygame is a library that is created for Python to make it easier to create video games. And while it does make it significantly easier to make video games, it is a huge library that has lots and lots of stuff in it. I could literally teach a class or maybe even two classes on just Pygame. So we're barely going to scratch the surface. And in fact, this is going to be the last lecture of this class. During our final exam day, I will be here. The classroom will be open, and you can come in and work on stuff or get questions answered or whatever. But I won't lecture on that day. So this is really going to be it. And this will be a relatively brief lecture. The way I've set this up is so if you want to go a little deeper into Pygame or spend some time with it, I've set up some good resources here. This Real Python tutorial actually walks you through the process of creating from scratch the game that I'm going to show you today, that we're going to use as kind of our starter. Also, this one is really good. This is part of the pygame.org website, but it's a tutorials page. And some of these are really good. Some of them are kind of lame. But if you want Pygame tutorials on specific topics, one of the nice things here is that you've got different types of games. It shows you how to do some different things in Pygame that you might be interested in or you might find useful. So the other thing here is just the main site for Pygame. And it walks you through lots and lots of stuff like installing, getting started. Of course, Pygame you can install through PyCharm package installer, just like all the other packages we've worked with. So you don't really need to do that. You can probably even find some Python developed games here, and I think some of these are developed in Pygame. So you can really do a lot of stuff in Pygame. It is actually a very robust library that allows you to create pretty decent games, honestly. And if you've gone back as far as I do with video games, we used to be satisfied with pretty basic graphics. In fact, some of these back in the day would have been cool. So that's my back in the day story for today. Obviously, we're not going to be creating like Fortnite or anything like that in here with Pygame. But if you're interested in that kind of coding, or if you're interested in making games, or you just like to do that kind of stuff, then we'll get you through the basics today. You will see that there's some sample code here under resources. This is the same code that I'm going to be walking you through in just a minute here, and I'm going to basically walk you through the code for developing a very simple game. And for the assignment, the minimum level of performance for this assignment is just to take this code and tweak it a little bit. Do something interesting, make it a little different, make it your own in some small way. And that will satisfy the requirements of this assignment. It's not a terribly difficult assignment, although what you'll see here is that the code itself will be a little bit intimidating, especially for those of you that struggle with some of the concepts in object-oriented programming, because Pygame is strictly object-oriented. So we will be getting into some classes and objects and things like that. So let's get into the code and take a look here. I'm going to show you the game first so that I can make reference to the parts of the game, and then you can see what it looks like. So I just want you to lower your expectations right now. This is a very basic game, but you'll see what goes into making a game. Okay, so when I run this, I've got a little airplane here, and I have little missiles that are coming from the right-hand side, and I can control it in 4 dimensions, and the whole idea is to go as long as you can without getting hit. It doesn't keep score, and in fact, even when you get hit by a missile, it doesn't really do anything impressive. It just quits. So right away, you can probably think of about 30 things you could do to improve on that game. I invite you to do that, to maybe change it from an airplane and missiles to something and something else. Figure out, instead of having them come from the right and go to the left, maybe you're a person on the ground who's running back and forth trying to dodge rocks that are falling from the sky or something like that. So there are a million variations on this game, and that sort of game has been done more times than I can count. So what's one or two more? And so with the code, we're going to start by importing the Pygame library and random, and then we actually get into excuse me, we get into some specifics. And if you remember when we used the from construct to import things, when we do that, we can actually refer to them by name. We don't have to say pygame.locals.kup. We can just say kup, because it imports that variable, that constant, directly into that. And all of these refer to specific keys and a specific formula or constant in Pygame. And so these are things that we're going to need later, but we're going to import them this way so we can refer to them specifically by name. So that's the import section. We can hide that now because we don't need it again. Okay, so right away you can see here, this is very well commented code. We're defining constants for the screen width and height. And this is in pixels, by the way, in case that wasn't obvious. So I can easily change the dimensions of the game if I want to. And then we're getting straight into it here. We're defining a class for the player, okay? And so you can see here, knowing what we know about object-oriented programming, that class player is based on another class, which I can actually go into, called the sprite object, right? If you double click on those, you can go into the parent or the super object. But pygame.sprite.sprite, okay, remember, we're referring to this thing that we imported. So in this library, there is a group called sprite and a specific class called sprite within that. So we're basing our player class off of something called a sprite. And in game terms, a sprite is a graphic object that you can move around the screen, or that moves around the screen. So all of those missiles that are coming from the right-hand side, those are sprites, as well as the player. So the player is based on a sprite. We know that this is the initialization of that object. So when we create that object, we're doing some things. And you can kind of, if you think about what we're doing here, right? And we think about what we learned in object-oriented programming, we're referring to the super here. So we're calling the initialization of the sprite class. And then we are creating, when we see the word surf, that's short for surface. Okay, the surface is the visible part of, that was very sneaky. Way to duck down. That's good. You definitely weren't distracting anybody. The surf refers to the surface of the sprite, which is the visible part of the sprite, or the area that it takes up. So you can see here, we are loading an image as the Pygame image for that surface. We are also setting what's called a color key. And the color key refers to what is transparent in that image. So it's saying that any white part of that image is going to be transparent. And it also is going to use that acceleration construct and that's not an acceleration of the sprite itself. It's actually a graphics acceleration. So it uses a formula that makes the graphics perform well. You don't even need to know what that means. You just leave it there. But this means this, if that image, if you can imagine that that image is a square picture with a white background that has a jet in it, drawn inside it, I'm saying let's make all that white background disappear in the game. So it looks like it's just the shape of a jet, but it actually has a white background that's been, anything that's white in that image is going to be transparent. So you can, and notice that this is a tuple with 3 numbers, and it's using the 0 to 255 for RGB, just like we did with the other colors in the graphical user interface in the images. So you can look those up, or you can, if you're in an image editing program, you can actually sample the pixel that you want to be transparent, the color that you want to be transparent, and you can get that number to plug it right in. And then this is just a function that takes all of this information and sets that rectangle. Okay, it basically says the size of this object is based on the surface size. Okay, and we need to know the size so we know when we hit something. This part of the code you can see here is moving the user based on what's pressed. So if I press the up key, the user is going to move 0 pixels to the right, and it's going to move down a negative 5 pixels, which means it's going to move up 5 pixels because the top corner of your screen is 0.0, and then this is like 800 by 800 and 600. So if I want to move up, I'm moving negative on the y-axis, if that makes sense. So down is just the opposite. I'm moving down 5. By the way, I can adjust these numbers to make my airplane move faster and slower. So each time I press a key, it's going to move 5 pixels. If I change that to 10, then it moves twice as fast. So I can make it move different speeds up and down than it does left and right. I could make it move really fast to the left and slow to the right. If there's a physics reason in my game to make that seem more realistic, that might be interesting. Actually, that actually is kind of a cool idea, right? I could make it move because it's kind of retreating or flying backwards. So now I'm moving slower this way, but a little bit quicker the other direction. Maybe that helps me avoid some of the missiles that are flying my way. So you can easily make adjustments to your game that way. It's good to start out with something that's basic and consistent, and then make adjustments once you get things kind of working. This section of code makes sure that the player doesn't fly off the screen. Okay, so it basically says if the left side of the rectangle is less than 0, meaning if the left side is off the left side of the screen, then let's freeze it here. We can't get less than 0. If the right side is bigger than the screen width, then stop it right there at the screen width. And then same for top and bottom. Basically, if you don't do this, you can actually physically fly the plane off the screen. Actually, let's just comment that out and I can demonstrate that. Okay, so if I want to fly off the screen, I can actually do that now. Because it actually, even though the screen is only a certain size, it actually does, Pygame actually recognizes coordinates that kind of go on to infinity on every edge of the screen. The edge of the screen is just where 0 is, but you can have coordinates that are less than 0 because you might have a reason why you might have a sprite that comes in off the edge of the screen. That's how those missiles work. They come in off the edge of the screen. Okay, so those are all things that are inside the update. So every time there's an update called on the sprite, it's going to check the keys and it's going to check the position, and it'll move the player unless it is at the edge of the screen. So every time there's an update called on a sprite, it does that. Now we have another class for the enemy. So we're creating a class, and then we're going to create 100 instances of that. So every instance of this class is going to be one of those individual missiles, but they all have the same ability. They all use the same graphic. Again, with the white background and the hardware acceleration. So we are going to put them into the screen at a random size or a random place between the screen width and the screen height. And also, we're going to set the speed of those things. The nice thing about a lot of these is that based on what you know already about Python, you can kind of infer what it is we're doing here. You know what random.randint does. It generates an integer between this and this. You know randint is going to generate something between 0 and the height of the screen. You can sort of figure this out. And you can figure out that the speed of the sprite refers to how much it moves. Okay, so now this sprite, I want you to notice, this sprite and this sprite both have an update function. And the reason they both have an update function that's exactly the same spelling, exactly the same case, is because we can put them in a group and we can say all sprites in this group update. And it will do whatever's in that update function all at the same time. And so that allows us to control all the sprites and have them do what they're supposed to. So this moves the sprite. You'll notice it's the negative of self.speed. Self.speed is a variable that holds a number. And so we're just moving it from right to left, which means we move the x coordinate by a negative of whatever the number is for that sprite. And if self.right, the right side of the rectangle is less than 0, in other words, if it goes off the left side of the screen, then we kill that sprite and it goes away. So a lot of these things are built in, like the kill function, and sort of some of these things just make it really easy for us to do some of these actions in the game, and it will keep track of that for us. So pygame.init initialization just starts the game. Now we're actually using the screen width and the screen height to set the display. And then we have this is when an enemy is actually added. Okay, and you'll see that when we add an enemy later on in the game. But basically, every time we add an enemy, we wait a little bit of time, and then we do it again. And each enemy has its own little ID number. That's what this is, so we can keep track of them. Player equals player. Okay, so we're just instantiating the player class, right? And we're putting it in a variable called player. Now we're doing enemies as a group. Okay, so all of the enemies are a group. And then we're creating another group called all sprites, which includes the enemies and the player. So we're adding the player, which is this variable, to all sprites. Okay, now running equals true. So we're setting up a while loop here that basically says while true. And we're starting the game clock, which allows us to control the frame rate of the game. Now, every time something happens in the game, so in other words, if there's an event, something happens. If the event type is key down, so we're looking for different key presses. If we want to type quit, if we want to hit the escape, then running turns to false, the game ends. If event type is add enemy, remember that back up here. Every time we do this, we run that. We have that event happen. So every 250 milliseconds, we add a new enemy, and new enemy is based on the enemy. And then we add it to all of the enemies group. And we add it to the all sprites group. And then we get any pressed keys. We run the player update. And here we run the update function of all the enemies. And then we fill the screen. And the final thing that we have to do is for each entity in all sprites, Blit is a function in Pygame that actually draws the stuff on the screen. Until now, none of those sprites have been drawn on the screen. They exist somewhere in the game, in the memory of the game. Blit is what puts them on the screen in the appropriate place. And this happens every time. If you think of a movie, right? A movie has frames. Every time we go through this cycle, it updates all the sprites. It checks all the things. It makes sure nothing's off the page and all that stuff. And then it draws the screen, fills the screen with blue, and then draws all the sprites where they are. Every single frame of the game. Boom, 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 boom. And that's what makes it look like things are moving. Okay? Right here, it's checking to see if the player is colliding with any sprites. So this is what happens when you hit one of the missiles. And the reason it's so boring, what happens is it gets rid of the player and immediately turns the game off. So as soon as running turns to false, whether it's through that or somebody quitting or hitting escape, the game window shuts. So it would be probably more fun if you kill the player and have an explosion happen or something, which you could have another sprite that you create that's an explosion sprite that does a little animation or whatever. And then flip the display is just the final thing of what it does. Blit actually doesn't draw them on the screen that you can see. It actually draws them on the next frame. So it draws everything on the next frame, and then display flip actually flips that frame into place. So it has a frame that's currently showing, and it has a frame that it's drawing. And that's how it does it quickly so that animation doesn't stutter, is it always has the next thing drawn when this one is doing its thing. So every time we have one showing, we have another screen that's being created by this Blit command. And then the last thing we do is hit flip, and clock.tick decides how many frames per second we do. So 30 is slow. So if I start at 30, looks like this. If I change it to 60, looks a little faster. So I can change how challenging the game is by adjusting the frame rate. See, now it's really hard. So you could have this number, just as a thought. What do games often do as you progress through levels? Well, they get harder. You could have the game actually speed up as somebody progresses. So each time this comes through, I could actually take this so it could start 30. Well, that would actually have to be way up here. And then down here, I could go int speed plus equals 1, and then int speed Now, the problem with this is that it's going to accelerate really quickly because I have so many frames. See, we already have reached supersonic missiles. But if I increase that more slowly, right, I could do that. I could have it get more and more difficult over time. So there are a lot of things you can do. If you just think back through the things that we know how to do and things that you've seen other games do, you can reverse engineer a lot of this code to make it what you want. But you can also come in here and put different, I'm not giving you the graphics, so you have to at least figure that part out, which shouldn't be difficult. But I encourage you to play around and see what other things you can change. Can you put a title up? Can you keep score? Can you figure out how to keep a score based on how long the user has lived on the screen? Can you save the scores? Make me like do a high score list or something. Like, what can you do to make this game your own? So that's kind of it. I've given you all of this. All this exact code is on the Canvas page, and if you're interested in this, it's a bonus assignment. You can get a point for it and substitute it for any other assignment in the class. And if you don't want to do it, that's totally cool too. But it's all there for you. And that concludes the final lecture of the class.